This week on the show, what ZFS block pointers are, zero-day rewards offered, KDE on FreeBSD status report, and new FreeBSD core team, NetBSD Wi-Fi refreshes, Poorman's continuous integration, and the power of Ctrl+T in this week's episode of BSD Now. BSD Now, episode 255. What are you pointing at? Recorded for the 18th of July, 2018. Hello, I'm your host, Benedikt Reuschling.
And I'm Alan Jude.
And as our title suggests, we have interesting headlines for you about the ZFS block pointers, with the title going, what ZFS block pointers are and what's in them. And what better person to explain them to you than Alan?
Well, actually, it's Chris.
Or at least read them to you.
Explaining it, yes. So we've covered Chris's blog on the show a number of times over the years. And he's a system administrator at a University of Toronto here in Canada and runs their big ZFS storage system. Actually, he's done a series of posts recently. I wonder if he's suddenly got some time off in the summer or what. But we're going to cover a bunch of it. But to start, he's going to dig into what a ZFS block pointer is and what's actually in there.
Oh, yeah.
So he says, I've mentioned ZFS block pointers in the past, for example, when he wrote some details of ZFS DVAs, which are the data virtual address. It's basically the location of where the data is actually stored. So the block pointer is this big structure, and in it, it contains 3 of these DVAs. And each one of those is basically which disk and, what sector on that disk. Although it's not actually disks, it's VDEVs. So in a RAID Z, the offset is actually relative to the entire array. So, if you have a RAID Z2 of 8 disks or something, when it says 12, it actually means, as if you counted across all the disks. And this is how the RAID Z expansion is able to work by reflowing the data and making sure that the same data lives at 12, it will continue to work. Anyway, he said, I said then that DVAs are embedded in block pointers, but I've never really looked carefully at what else is in block pointers and what that means and implies for ZFS. So a very simple way to describe a ZFS block pointer is that it's what ZFS uses in place of what other file systems would simply put a block number. So you know how on, say, UFS, you have inodes with just a number. In ZFS, a block pointer is much bigger. Instead of just being a number, it's a 128 byte, not bit, byte structure that contains a lot of data.
But you're always out of inodes, but never out of block pointers.
Yeah. Just like block numbers, but unlike things like, say, a ZFS dnode, which is actually the thing slightly more equivalent to an inode, a block pointer isn't a separate on-disk entity. Instead, it's an on-disk data format and an in-memory structure that shows up in a bunch of other places in ZFS. So to quote from a draft of the old ZFS on-disk specification, a block pointer, or block pointer T, is a 128-byte ZFS structure used to physically locate, verify, and describe blocks of data on disk. Block pointers are embedded in any ZFS on-disk data structure that points directly to another disk block, both for data and metadata. For instance, the dnode for a file contains block pointers that refer to its data blocks. If the file is small, or if it's bigger, the dnode will actually point to some indirect blocks, and each of those will then either point to more indirect blocks or to the data blocks, and it just keeps going until you eventually get down to data.
Makes sense.
So as he described in another blog post, however, as he discovered when he paid attention, most things in ZFS only point to dnodes indirectly by giving them, by accessing them via their object number, which is kind of, again, like an inode. And so basically everything in ZFS is actually an object store that's just exposing to you a POSIX interface. So what's in a block pointer itself? You can find the technical details for modern ZFS in the spa.h file. So he'll just give a short summary here, but if you want the details, including the ASCII art diagrams, they're in the linked file there. So a regular block pointer contains various metadata and flags about the block pointer and what it is for and what it means, including the type of object that it points to, whether it's a file or a directory or whatever. Then there are up to 3 of those DVAs, which are exactly what they say. It's the pointer to where on disk the data actually is. The reason why there are 3 is that copies property. You know how you can set copies equals 2 on a data set, and then every time you write data, it'll be stored twice? Well, the way it does that is by putting a second address for that data in the block pointer. And then it says it's here on disk, and it's also here on a different disk, hopefully. And that way, if one of the copies is bad, it can get the other one. Part of the reason for this, you think, well, most people don't ever set copies to 2 or 3, but metadata does. So the metadata, if it's important, has 2 copies, and if it's really important, has 3 copies. And this way, no matter what happens, ZFS stands a good chance of being able to keep working and not corrupt the file system. It also has the logical size, so that's the size before compression and so on, and the physical size, which is the size after compression rounded up to sector sizes and so on. However, the physical size can do odd things, as it's not necessarily the A size, which is the allocated size. Because those could be different across different VDEVs and so on. It also knows the transaction group when the block was born, both logically and physically. So the physical transaction group is that of when the first copy was written and so on. The physical transaction group was added as part of the ZFS dedupe feature, but is also used in the VDEV removal code as well. Then the other thing that's in the block pointer is the checksum. So the checksum of the data that the block pointer describes. So you have your block of data, and then you have a block pointer that points to it, and it contains the checksum. And if you remember, we said that we often have these indirect blocks that just point to other block pointers. So, if we have the checksum of the data in the metadata, how do we know that the checksum isn't corrupt? Well, it's because that metadata is covered by a checksum of the higher level metadata that points to it, which is covered by a checksum of the higher level data that points to that, all the way up to the top of the tree where you get the uber block, which again it's a checksum. And what happens is when you import the pool, it looks at the list of uber blocks, finds the newest one, and tries it. If the checksum in it pointing to the first high level data block, if the checksum doesn't match, it probably means that the machine crashed or powered off or whatever before that uber block was finished writing. So it goes back one, and it keeps going back until it finds one where the checksum does work. And that's how your file system is always consistent when it comes up, and why you don't have to wait for an FSCK or something.
Yep, it's self-validating.
Yep. Just like basically everything else in ZFS, block pointers don't have an explicit checksum of their own content. Instead, they are implicitly covered by the checksum of whatever embedded them. So you don't want to store the checksum for the block pointer in the block pointer, because then writing the checksum in the block pointer will change the checksum of the block pointer. And it gets much more complicated to decide to exclude some portion of the block pointer, especially if it ends up not being the end and so on. And so instead, it's stored in the higher level.
Okay.
Right. Instead, they're implicitly covered by the checksum of whatever's embedding them. So the block pointer in a D node are covered by the overall checksum of the D node. Block pointers must include a checksum of the data they point to, because that data is out of line from the containing object. And block pointers in a D node don't necessarily point straight to data. If there's more than one bit of data in whatever the dnode covers, the dnode block pointer will instead point to some level of indirect blocks, which have a checksum, and point to another indirect block maybe that has a checksum, and then eventually down to a data block. There's also a special type of block pointer called an embedded block pointer. Especially once we got in compression, sometimes the amount of data you need to write gets really, really small. Especially, something like an empty directory, or you created a file but haven't written to it yet, or you just have a small text file, right? A timestamp or something. With embedded block pointers, you can fit up to 112 bytes of data directly in the block pointer as part of the metadata, instead of having to put it, instead of doing the extra effort of actually allocating a block and pointing to it from that block pointer.
Oh, that's the one option where you can use on ZFS send.
Yeah,
with embedded block pointers.
Yeah. So what embedded block pointers do basically is steal the space from those 3 DVAs, right? Because the DVA has the ID number of the VDEV and the offset, and that's a 64-bit number. And then you have all the space from the checksum, which is a 256-bit number, and it allows you to just reuse all of those chunks and only have to keep track of a couple of things like the flags. Is this compressed or not? What's the size supposed to be? The very basic information. And the other bits, the block pointer, are, instead of containing a DVA and a checksum, contain the actual data of the block. So there's no checksum. But because that embedded block pointer is pointed to by the higher level object, it has the checksum.
Okay. And there's also mechanisms, if the file grows, then it has to be able to move out of that pointer and be a separate object again.
See, when the file grows, you're writing new blocks. You never overwrite.
Copy and write,
so you never modify something in ZFS. You would write a new block pointer, and it's big enough so it's not embedded, so you'd have a regular thing, and then you update the chain all the way up.
Oh, right, yeah. How can I forget about copy and write?
Yes.
Okay.
So basically, all it contains is a little bit of metadata and the logical birth time, and we use that in order to deal with the embedded block pointer. And it means it can save a lot of work and a lot of space by not having to allocate more extra blocks and indirect blocks and so on, since it's just a tiny bit of data. Since block pointers directly contain the address of things on disks in the DVAs, they have to change anytime that address changes, which means anytime ZFS does a copy on write thing, this forces a change of whatever contains the block pointer, which in turn ripples up to the block pointer that pointed to that, because now the checksum is going to have changed and which block pointer you're pointing to, and so on. And so on until eventually you reach the meta object set, which is the top level metadata for each data set. And then the uber block. How this works is a bit complicated, but they have linked to more detail if you want to know. But ZFS is designed in general to make this a relatively shallow change and not have to go many levels to do it. In particular, they cover how changing a file in a directory doesn't necessarily change the directory and cause an extra level of metadata changes.
Yeah, which
like
would be a little bit overhead.
Right. In some file systems, when you change a file in a directory, that changes the directory and you end up writing a lot. In ZFS, that would just cascade out of control. Because if you change the directory, well, that directory probably is contained by a parent directory, which is contained by... And then each of those is like you're writing 2 or 3 copies of the metadata and you're modifying the chain all the way up, and it would quickly get out of control. So Chris goes on. As far as I understand things, the logical birth transaction of the block pointer is the transaction group in which the block pointer was allocated. Because of ZFS's copy on write principle, this means that nothing underneath the block pointer has been updated or changed since that transaction group. If something changed, it would be rewritten as a new block with a new transaction group number, which would have forced a change of at least one of the DVAs and thus ripple all the way up to the top. This is how ZFS incremental sends are so much faster than rsync. Instead of having to go through every file and check when it's modified time, you can just at a much more simple level in ZFS just say, find every block that has a birth time newer than the last time we did replication. And that will give me every block that has changed. Or, if you're doing incremental between two snapshots, you can just get everything newer than this, but older than that, or whatever. So, however, this doesn't quite mean what I used to think it meant because of ZFS's level of indirection. If you change a file by writing data to it, you will change some of the file's block pointers, updating their logical birth times, and you will change the file's dnode. However, you won't change any block pointers, and thus any logical birth transactions of the file system directory that the file was in, or anything else up in that directory tree. Because the directory refers to the file through its object number, not by directly pointing to its dnode. You can still use the logical birth transaction to effectively find files change from one transaction group to another, but you won't necessarily get a file level view of these changes, right? Because if you change the middle of a file, only maybe the block in the middle actually changed. The whole file didn't change. Instead, as far as I can see, you will basically get a view of what objects in a file system have changed, effectively the equivalent of the inode number. However, ZFS has an interesting hack to make things like ZFS diff work far more efficiently than you would expect them to be able to do. And that's going to be yet another entry to cover. So next week, we'll talk a bit about how ZFS diff is able to go from block number 1017 changed to being able to tell you it was this file that changed, going from the object number to the file name.
Oh, that's great. Yeah, so that's our little contribution to you understanding more from ZFS internals. And actually, you don't have to understand all of that. It's just working, but in certain cases, it's good to understand why the system behaves the way it does.
It's useful to think about things like how the embedded block pointers work, and just, for example, even you just for a second there forgot that copy on write is going to mean work this way, or be like, but embedded block pointers don't have a checksum. How's that going to work? It's like, oh, right, it's covered by the checksum of the thing that points to the embedded block pointer. So here's the diagram of what a block pointer looks like. So you see there's a little bit of padding there, and then you have the VDEV number, this grid field, which isn't currently used, but is eventually available for some interesting ideas they had. Then you have the allocated size, so how big of the chunk on disk it was actually written to. And then there's a 1-bit flag there, and then 63 bits to store the offset. And then you have the same thing for the second DVA and then a third DVA. Then you have a couple more flag fields, the level, so each level of indirection, the level number goes up, what type the block is, what kind of checksum it is, if it's an embedded block pointer, what compression algorithm it's using, the physical size, and the logical size. Then there's some padding. It's basically not used, but will be available for some invention in the future. The physical and logical birth times, the fill count, and then the 4 separate 64-bit chunks that make up the 256-bit checksum.
Okay.
And then, there's a flag that controls the byte order, whether it's big endian or little endian, flag to mark whether this block is participating in dedupe or not, if it's encrypted or not, if it contains embedded data, etc.
Yeah, so that PDF actually contains a lot of good information if you want to really get deeper into that than we already are.
The one I'm looking at right here is the actual source code of ZFS, because embedded block pointers didn't exist when the original PDF came out.
Oh, sure.
So here you can see the diagram of the embedded block pointer. You see that all that chunk where the DVAs were is all just payload. The padding, including the physical birth time, is all payload. And then the checksum and so on is all payload. So we just have the type, the compression, the sizes, and the birth time. And then the rest of this is all the data.
Okay, yeah, that's it.
Yep.
Okay, but it's not all in this show, although Alan could probably talk a whole show about just that. We have another story called rewards of up to 500 million offered for FreeBSD, OpenBSD, NetBSD.
500,000.
Yeah,
it's a lot of money, but it's not $500 million.
Yeah, yeah, it's just a couple of zeros. So 500,000 offered for FreeBSD, OpenBSD, NetBSD, Linux, and 0 days found in those systems. So it's
so
a bit more information over at leapingcomputer.com.
Yep, but ZeroDem, which is a one of those kind of evil exploit brokers, they sell governments and other people exploits against operating systems or computer software and browsers and so on. And if you find a exploit in one of the BSDs, they're willing to pay up to $500,000 for it. If you're a good person, you probably give it to the security officer of the project instead. But
yeah,
what's interesting about this is just that they're willing to pay that much for a BSD 0 day. And basically that they're putting it on par with a Linux 0 day. Whereas before, it was like 1/10 of that.
Yeah, not even close, yeah. So yeah, the story goes like this. The exploit broker ZeroDem is offering rewards of up to, say again, 500,000 for 0 days in Unix-based operating systems, OpenBSD, FreeBSD, NetBSD, and also for Linux distros, such as the Ubuntu's, CentOS, Debian, and Tails of this world. The offer, first advertised via Twitter earlier this week, is available as part of the company's latest 0-day acquisition drive. ZeroDem is known for buying 0 days and selling them to government agencies and law enforcement. Because why not? Yeah, the company runs a regular 0-day acquisition program through its website, but it's often holding special drives with more substantial rewards when it needs 0 days for specific categories. I guess they ran out of 0 days at that point, so they need more, so they increase the money. That's good, actually, for comparing the the strength of the BSDs also in comparison to the Linuxes, like in visibility.
Mm-hmm.
And so the US-based company held a previous drive with increased rewards for Linux days, 0 days, in February, with rewards going as high as 45,000. Well, that's pale in comparison. But in another 0-day acquisition drive, they announced that the company was looking again for Linux 0 days, but also for exploits targeting the BSD specific systems. And with this time around, rewards can go up to, as we mentioned, 500,000. See, now I get it. For the right exploit. So you not just have to have a little bit of exploit, but the right one. ZeroDem told Bleeping Computer they'll be aligning the temporary rewards for BSD systems with their usual payouts for Linux distros. The company's usual payout for Linux privilege escalation exploits can range from 10,000 to 30,000. Local privilege escalation, or LPEs, rewards can even reach 100,000 for an exploit with an exceptional quality and coverage, such as, for example, a Linux kernel exploit affecting all major distributions. Yeah, and then everyone's hell will break loose. Payouts for Linux remote code execution, or RCE, those can bring from 50,000 to 500,000, depending on the targeted software or service and its market share. Of course, higher market share, higher payout, because higher damage. The highest rewards are usually rewarded for LPEs and RCEs affecting CentOS and Ubuntu distros. Yeah, because CentOS is also certified for a lot of big company systems like SAP and such. And if there's some exploit there, then companies are really screwed. So 0-day price.
Also generally based on the level of user interaction required. You know, if it doesn't require the user to do anything versus if, it takes 1 or 2 clicks, or if the system has to be configured a certain way or whatever.
Yeah, how easy it is.
just wanted to cover this one because BSD getting that level of being sought after at the same level as Linux was interesting. And also specifically that they talked about 0 days in servers are especially interesting to them.
Yeah, and as the chat room points out, of course, the CentOS and Red Hats of this world are also used in government roles. That's why this ZeroDem is also finding those for governments and selling it to them. So the acquisition price of a submitted 0 day is directly linked or tied to its requirements in terms of user interaction, as Alan said. Other factors include the exploit reliability, like its success rate, the number of vulnerabilities chained together for the final exploit to work, like more chained bugs mean more chances for the exploit to break unexpectedly, and the OS configuration needed for the exploit to actually work, like is SE Linux activated or not. Exploits are valued more if they work against default operating system configs, because some people just install the default operating system and don't care about tweaking it or securing it. You know those folks. So 0 days in servers can reach exceptional amounts, whatever that means. So the bar is open.
the price for FreeBSD exploit is suddenly more than 10x what it normally is.
Yeah. So the article continues. Price difference between systems is mostly driven by market shares. ZeroDem founder Chowki Bekrar told Bleeping Computer via email. Asked about the logic behind these acquisition drives that pay increased rewards, Bekrar told Bleeping Computer the following. Our aim is to always have, at any time, 2 or more fully functional exploits for every major software, hardware, or operating system, meaning that from time to time, we would promote a specific software or system on our social media to acquire new codes and strengthen our existing capabilities or extend them. We may also react to customers' requests and their operational needs. Okay, well, that's what those companies would typically say. So it's becoming a crowded market. Since ZeroDem drew everyone's attention to the exploit brokerage market in 2015, the market has gotten more and more crowded, but also more sleazy, with some companies being accused of selling 0 days to government agencies in countries with oppressive or dictatorial regimes, where they're often used against political opponents, journalists, and dissidents instead of going after real criminals. Yeah, that's the bad side of that game. And the latest company who broke into the 0 day brokerage market is Crowdfence. Oh, okay. I see where this is going. Who recently launched an acquisition program with prices of 10 million, of which it already paid 4.5 million to researchers. So there's a bit left. Yeah, so you can make money from exploits, either by exploiting it themselves or by selling the exploit to those companies.
But you probably shouldn't. Again, you only brought up the story.
How about contacting the...
It was newsworthy that FreeBSD was getting the same level of desire for these as Linux.
Sure. And the really cool people find the exploits and report it to the operating system security teams and give them time to actually fix those exploits before going public.
So this week's episode of BSD Now is brought to you by DigitalOcean. Head over to digitalocean.com and check it out. You can get a FreeBSD powered server for just $5 a month with 1 gigabyte RAM and 1 virtual CPU and 25 gigs of SSD backed storage. Or, you can spend a little bit more and get 2 or 3 gigs of RAM or 2 or 3 vCPUs or whatever.
Yeah. And they offer, in the security space, they provide cloud firewalls or private networking so that you can communicate between your droplets in the same data center in a secure manner. And the cloud firewalls secure your infrastructure from the outside world. You can define which ports should be open, which ones should be blocked, and those are pretty tightly secured this way.
Yep. If you don't have an account already, go over to do.co/BSD Now, and that page will take you to the super secret page where you can get a $100 credit for the next 60 days to try out DigitalOcean instead of just taking my word for it. But you trust me, so you should just take my word for it. If you already have an account, if you go under your in the billing tab, you can enter a coupon code. If you put FreeBSD Now in there, it'll add $10 to your account.
Yeah, and that gets you started already with a bunch of things you can do.
The $10 doesn't expire.
Yeah, that's pretty much for longer than the other coupon code. And I mean, just with those $10, that's how I got started. And I had enough time to test everything out, and I liked it, so I gave them my credit card details, and now I'm running it for a number of months, actually. So it's almost a year. So I'm totally happy with them.
Well,
they provide the
I
right
had
services.
to insist that you actually be on IRC for more than 4 minutes at a time as your Mac would go to sleep constantly. And it was impossible to get a message to you.
Yeah, small things like that can make a big difference. And now I'm actually complaining about other people. Why are they always dropping out of important IRC communications? And but it could be anything on that server. You can run your little block there.
Soon we'll have converted Warner over.
That's our next goal. Yeah. Yeah. So start your droplet and experiment with it. And because some people are just sitting behind their little firewalls and networks and are like, they never make the jump into the big ocean, the internet. But once you have your block there or whatever service you think are needed to contact via the internet that you always want to be reached on, then yeah, try out DigitalOcean. And you can find a lot of good community how-tos in the community sections that get you started if you want to know, how do I set up a block with, I don't know, that block software with Hugo or Jekyll or whatever it is.
Yep. And they also have the CPU or memory optimized droplets. So if you need more memory or more CPU than the default set, then you just scroll down and they have those types right there at the bottom.
Yep, that's the details. And yeah, browse the website and they have comprehensive docs for everything if you need to read up a little bit beforehand.
Yep. Moving on, we have some news from the FreeBSD KDE team.
Oh yeah, we haven't heard from them in a while, so it's good to have an update. So they have more news.
It's been a while since I wrote about KDE on FreeBSD, and what the third-party software developers and so on are up to. We're better at keeping the IRC topic up to date if you want to check out KDE-FreeBSD on Freenode. Then a lot of other sources of information, including remembering to update the FreeBSD quarterly reports.
yeah, that's a to-do for me as well in the higher.
Although actually,
things.
Reminds me, I saw there's a request for assistance if you would like to help out with FreeBSD. The team that manages those quarterly reports is looking for some help to harass people into submitting stuff and then editing those into a useful report.
Yeah, that's the plan. Yeah, but now back to the KDE story.
Yeah. So in no particular order, interesting things that have happened recently. Qt 5.10 has landed in a Franken engine incarnation. They're still using the web engine from Qt 5.9 because, as I've said before, web engine is such a gigantic pain to update that all the necessary patches to get it compiled aren't quite sorted out yet. The collection of downstream patches to Qt 5.10 is growing slowly. None of them are upstreamable, like, say, LibreSSL support, though. So not much hope of that one getting cleaned up. The KDE frameworks releases are generally pushed to ports within a week or two of their updating. Actually, now that it's a bigger stack of KDE software and FreeBSD ports, the updates take slightly longer because we have to do a whole exp run to make sure it doesn't break everything, since a bunch of non-KDE things depend on Qt, for example. Similarly, applications and Plasma releases are reasonably up to date now. Dodged a bullet by not jumping to Plasma 5.13 right away, it turns out. Says Tobias is the person doing most of this work on these updates, and there's a pint of something this summer. And then the freebsd.kde.org website has also been updated since it was terribly out of date.
That's also good.
Nice. So yeah, we're mostly most update and mostly all packaged up and ready to go. Most of my day is spent in VMs packaged by other people, but it's good to have a full KDE development environment outside of that as well. And thanks to Thomas for the amazing application for downloading and displaying Flamingo.
Yep, you get a nice display here. So yeah,
thanks
KDE
to source code, not to Flamingo.
Yeah, that's important to know. Yeah, definitely check out KDE team, and if you can help in that area, they will be welcome to get a little bit more hands on that, because it's a huge application or a stack of applications that need to work together. So, welcome back to the news roundup this week. You might have heard it through the grapevine already, but there's a new FreeBSD core team elected. It's July 4th, actually, when that happened. And the announcement goes, dear FreeBSD community, active committers to the project have elected your 10th FreeBSD core team.
Yep. In alphabetical order by first name. It was interesting. The old core team, nobody had a first name in like the second half of the alphabet at all.
Yeah, that was interesting.
Yeah,
sorting
like,
wise.
as if they just sorted us and just took the top couple people. Anyway, so this year, for the next 2 years, the core team will consist of Alan Jude, never heard of him before, Benedict Reuschling, Brooks Davis, Hiroki Sato, Jeff Roberson, John Baldwin, Chris Moore, Sean Chittenden, and Werner Losch.
Yeah, these are your new evil overlords for the next 2 years.
Yes.
Elected overlords.
Quite a good core team, so I'm very happy with the results there. And we'd like to extend our gratitude for those who ran away, didn't run again. Baptiste Dresson, Benno Rice, Ed Mast, and George Neville-Neal. And also a big thank you to Matthew Seaman, who's acted as the core team secretary for the last 2 or 3 sessions.
Course, yeah.
Yeah. And thanks again to Joseph Monroe for stepping up to fill that role for us so that we have a core secretary.
Yeah, so that is also an important role within core to, herd the cats.
Yeah, well, to make sure we actually answer our emails and
and be on time for
things
meetings.
get done.
Yeah, it's not too small of a role.
Also, big thanks to Dag Erling Smorgrave for running the election system.
Yeah, that's also important to have an independent person who's not voting to run that system. Otherwise, it's you manipulated that, and yeah. So yeah, I remember we vote in FreeBSD every 2 years. Committers who have a commit bit can select up to 9 people, and if they don't like our noses after 2 years, then they can elect another one or run for themselves.
Yes. So the way the system works, basically, every 2 years there's an election. So there's a date where we then have, I think, is it a week? Yeah. There's a week period where anyone who's committed something to one of the FreeBSD repos in the last 365 days can put their name and a short description of their platform or whatever you want to say. And then after that, everybody who is eligible by that same criteria has 4 weeks to vote and pick the 9 people they would most prefer be the core team. And then at the end of that, the 9 people with the highest number of votes become the core team for the next 2 years. And then another election happens 2 years, or I think if the number of people on the core team falls below 7 or 6.
There's an early election one.
Yes. If some, that's never happened, and I don't imagine it would, but
just in case that this situation comes, we have a rule for that. Yeah, so governance is a whole different topic, but it's also important to see how each project deals with that kind of leadership decision and roles.
Yep.
Okay, so now you have to be even more proud that we're not just doing the show, but also a little bit of governing in our own little world.
Although part of the question is, did we just get elected because we're the noisiest.
It's like, yeah, oh, I've seen these guys before. It's like, how bad could it be electing those? Yeah. No, actually, we found out that I'm the only European person on the core team.
This time, yeah.
Yeah, so that makes it interesting. But yeah, it's definitely a good team of people that are engaged and want to make some changes in a good way. All right. We have also news from NetBSD Wi-Fi refresh, and this is over at the TechNet archive. The mailing list there from Phil Nelson. So this goes, the NetBSD Foundation is pleased to announce a summer 2018 contract with Philip Nelson to update the IEEE 802.11 stack, basing the update on the FreeBSD current code. So the goals of the project are minimizing the difference between the FreeBSD and NetBSD 802.11 stack, so future updates are easier. So 802.11 is the whole Wi-Fi specification. Adding support for the newer protocols 802.11n and 802.11ac. Improving SMP support for the IEEE 802.11 stack and adding virtual access point support, as well as updating many NIC drivers as time permits for the updated 802.11 stack and VAP changes, which is the virtual access point. So status reports will be posted. And every week. Oh, wow. While the contract is active, so I guess we have a bunch of news coming up in future episodes. Yeah. Okay. Yeah, great to have that initiative. And there will be good news coming to NetBSD, I guess, in the future with Wi-Fi. So if you have a toaster that can do Wi-Fi, it will do Wi-Fi even better in the future.
Well, I imagine this part is just like a lot of the wireless in FreeBSD. It's about making it so you can run your development platform on your laptop.
Or all these embedded devices that NetBSD runs on will also have good Wi-Fi support. And not that it has bad support right now.
A lot of those are quite a bit different.
In terms of the stack or in the way they do
like they're not a regular, PCI device. They're SDIO or whatever. But because this project is porting the FreeBSD stack over to NetBSD, they're not going to gain support for weird devices that FreeBSD doesn't have support for or anything like that.
Yeah, that's
but
true.
It will help them catch up for laptops.
Yeah, sure. And it tells people, hey, the stacks haven't diverged too much between the BSD, so there's still code going back and forth.
They're going to try to de-diverge them, but yeah.
De-diverge, that's a good word.
Reconverge is a better word, but
yeah, joining.
It doesn't mean the same thing.
Okay.
This week's episode of BSD Now is brought to you by IX Systems. If you go over to ixsystems.com/BSD Now, you can find out how open source storage is disrupting the enterprise market.
Yep, head over to IX Systems and look at what they have in offers in terms of new servers that you might need for an open source project that you plan to do. Maybe it's a new Postgres server you're running, or you want to build up a great storage systems because your disks are about to fill up and you need something that's future-proof. You can add more disks to it over time. And IX Systems are exactly the experts who can help you build such a system, sell you such a system, and also spec it to the needs that you have. Be it, I need a little bit more RAM than the standard off-the-shelf configuration, or I want to run that specific application, then tell them. And they will know, that one. We know exactly which components work best with that.
Yep. Whether you need to build a hyper-converged cloud environment, or are just trying to get your one workhorse server that'll do everything, they can help you with that. They also have a blog post that just came out, I think from our friend Michael Dexter, talking about the difference between NAS and SAN. For quite a few years, a SAN was a special higher performance kind of storage system. And mostly it came from the idea that a SAN was a storage area network, which basically meant you had a dedicated network just for storage. But the reason to have that, it wasn't so much that that was necessarily a better way to do it or anything. It was just that you wanted your storage to be fast, and gigabit Ethernet wasn't fast enough, so you had fiber channel or InfiniBand or something where you could get higher speeds. But now that you can easily get commodity 100 gigabit network, or you can have your choice of 10, 20, 25, 40, 50, or 100 gigabits, you might as well just have it on your regular network. Then you don't have to have twice as much networking gear, and having everything be the same means it all just works together. So they have a blog post kind of talking about the false dichotomy between a NAS and a SAN, now that almost all, even SANs that you buy now, are just connected via a regular Ethernet. There are other things where you have like direct attached storage, but in that case, it's not a NAS or a SAN.
Yep, that's the distinction there. And I guess storage is one of the areas where you can definitely get a good system from IX systems for extendability and performance and capacity.
Yep. So get in touch with them, let them know what you want to do, and mention that you heard about it on BSD Now.
Yep. For example, it could be a CI system, like in our next story. There is Poorman CI.
Takes lots of compute power.
Because continuous integration builds a lot of systems in a short amount of time. So we have Poorman's continuous integration hosted CI for BSD with shell scripting and duct tape. So this is over at GitHub, an article. So what's this? The Poorman CI, or PMCI, Poorman's continuous integration, is a collection of scripts that's taken together, working as a simple CI solution that runs on the Google Cloud. While there are many advanced hosted CI systems today, and many of them are free for open source projects, none of them seem to offer a solution for the BSD operating systems, FreeBSD, NetBSD, OpenBSD, etc. The architecture for Poorman CI is system agnostic. However, in the implementation provided in this repository, the only supported systems are FreeBSD and NetBSD. Support for additional systems is possible. So Poorman CI runs on the Google Cloud. It is possible to set it up so that the services fit within the Google Cloud's always free limits. In doing so, the provided CI is not only hosted, but it is also free, with a disclaimer attached: I'm not affiliated with Google and do not otherwise endorse this product, in the article. So that's important to know. And then they talk a bit about...
to be able to make it fit in the always free category, though.
Yeah, because you think you would use up a lot of resources this way. And then you go over the limits, but yeah, if it fits in that space, then yeah, why not? So they talk a bit about the architecture. A CI solution listens for commits, or more usually push events, builds the associated repository at the appropriate place in its history, and reports the result. Did it work? Did it break? What came up? Poorman's CI implements the very basic CI scenario using a simple architecture, which we present in this section. So that consists of following components and their interactions. So there's the controller, which controls the overall process of accepting GitHub push events and starting builds. The controller runs in the Cloud Function environment and is implemented by the files in the controller source directory. It consists of the following components. So there's a subcomponent here, the listener, which listens for GitHub push events and posts them as work messages to the work queue, publish, subscribe. There's a dispatcher, which receives work messages from the work queue, publish, sub, and a free instance name from the builder pool. It instantiates a builder instance named in the Google Compute Engine environment and passes it the link to a repository to build. And it goes along. Collectors are also available, or part of the architecture, which receive done messages to the done queue, publish, subscribe, and post the freed instance name back to the builder pool so that you know which one finished. And then there's the publish, subscribe topics.
The 4 pub sub or 3 pub subs we just talked about, right? The work queue, the pool queue, and the done queue.
Yeah, right. So the builder actually is a compute engine instance that performs a build of a repository and shuts down when the build is complete. Otherwise, it would just continue forever. A builder is instantiated from a virtual machine image and a startx, which is a startup exit script. And of course, build logs. You want to know what happened during the build. Are there any error messages? A storage bucket that contains the logs of builds performed by builder instances, as well as a logging sync. A logging sync captures builder instance terminate and delete events and posts them into the done queue, because you want to know, did this actually run through to the end? And of course, you want to monitor that log. Bugs are also a part of the article here. The builder pool is currently implemented as a pub/sub. Messages in the pub/sub contain the names of available builder instances. Unfortunately, a pub/sub retains its message for a maximum of 7 days. It is therefore possible that messages will be discarded and that your PMCI deployment will suddenly find itself out of builder instances. If this happens, you can reseed the builder pool by running the commands below. However, this is a serious bug that should be fixed, and for a related discussion, there's a little link here. So then you would run your 3 commands to actually rebuild this. The dispatcher is implemented as a retry background cloud function. It accepts work messages from the work queue and attempts to pull a free name from the pool queue. If that fails, it returns an error which instructs the infrastructure to retry. Because the infrastructure does not provide a retry control, that currently happens instantly, and the dispatcher spins unproductively around in nowhere. This is currently mitigated by a sleep or a set timeout, but the cloud function system still counts the function as running and charges it accordingly. While this fits within the always free limits, it's something that should eventually be fixed, perhaps by the pub/sub team. And there's also a related discussion for that one. It's an interesting approach, architecture-wise, and there's of course pictures to actually explain this a bit better than just listening to it. And yeah, so for people who want to run this because they might not have such a big CI need at the beginning at least, then this might be something to start with.
Yep. And lastly, for the roundup, we have a blog post here about the power of Ctrl+T.
Yeah.
Did you know that you can check what a process is doing on FreeBSD by pressing Ctrl+T? Has it happened to you before that you're waiting for something to be finished and it's taking a lot of time and you wonder why, but there's no easy way to check the status, like DD or CP or MV or many of the others? Well, all you have to do is press Ctrl+T when the process is running. This will output what's happening and will not interrupt or mess it up in any way. This is, when you press Ctrl+T, it causes your terminal to send SIG-info to the process, which usually results in 1 or 2 lines of feedback. So in the example where they're running ping to pingtest.com, and then you can see when they press Ctrl+T, the first thing they get back is the line from the operating system. This tells you the load average of the system, which command you're running, ping, its IP address. Then it shows in square brackets there the wait channel. In FreeBSD, whenever a process is sleeping and not working, it sets a message describing what it's waiting for, why it's not working. In this case, it's waiting on the select system call, basically waiting for the ping response to come back or for the delay between pings to expire so that it can send another ping. Then it shows how long the process has been running, what percentage of user CPU time and what percentage of system CPU time it's using, how much CPU is in use on the system in total, and how much memory this process is using, 2.5 megabytes. Then, many applications will actually output their own line when they receive the SIG info. So in the case of ping, Ctrl+T will cause it to print how many packets it has sent, how many packets it has received, the percent packet received rate, so 100% means no packet loss, and it also prints out the minimum, average, and maximum time of the ping so far.
Oh yeah, so each application can respond to that Ctrl+T by implementing their own outputs.
Yeah, if the application has a SIG-info handler, it will print its own information. But the kernel will always print its bit as well. So sometimes you get 1, if the application doesn't have any support, you only get the kernel's information. But if the application does have support, it can give you more. For example, if you're using Poudriere, the package building system for FreeBSD, when you hit Ctrl+T, it tells you what each individual worker is doing, which, on my system, there's 32 workers. So that's more than one screen full of data.
A lot of output, yeah. Or you can even, in simple shell script, run a trap command of a function that should be called when that signal is received, and then your little shell script will tell you something.
Exactly. So another example, CP. So I'm copying an ISO file to dev null in this case. And when I hit Ctrl+T, I can see the load average. I can see CP is running, or actually it's in the runnable state, meaning it could be running, but something else is currently using the CPU. It shows how long it's been running, how much CPU time it's using, how much CPU is being used, and how much memory it's taking. And then CP prints out the progress, saying, it's been 15, 32, and you can see as it prints out the progress. So you can actually see, in this case, it's 95% done. It'll be done in a couple seconds.
Almost there, yeah.
Or wget. While it's downloading, you can hit Ctrl+T, and it will print out this same extra information.
I know that TCP dump under FreeBSD does the same. It shows you how many packets it already captured. So
yep.
Try it out in any kind of application. You might find some information there that I haven't seen before.
Right. So DDing an image to a thumbstick, Ctrl+T tells you how much is done so far, what the current rate average is for the rate, etc. Lots of things. There's actually also some work going on to optionally have, when you press Ctrl+T, in addition to that one line you get from the kernel, there's a debugging set that's coming that will print the current stack trace for the whole kernel. So if you're waiting on something in the kernel, it'll tell you exactly what you're waiting on, so that if something is getting stuck, you can see where without having to, do the extra work of attaching a debugger and getting a stack trace or whatever. So I'm looking forward to that too. So the bad news is that Ctrl+T doesn't work on the Linux kernel, but it does work on Mac OS because, again, inherited from BSD.
Yep, and they also have a nice way of having these handlers implemented and show you certain things on the system.
Yep. And they give a big thank you to Mark Felder, for teaching them about Ctrl+T.
Yeah, it's like you could use a BSD for years without knowing that, and then you discover this sometime, and it's like, whoa, why didn't I? As soon as
you discover it, you miss it on every system that doesn't have it.
Yeah, it's like, why is it not being output? Oh, I logged into a Linux system.
Yeah.
And
like, even just during boot, and you're just like, what's taking so long? Ctrl+T.
Yeah. As soon as you get
as soon as something isn't going as fast as I want, it's like, why? What am I waiting for?
What's the problem here?
Yeah, if it's ZIO CV, that means it's waiting on some IO in ZFS. If it's BLKRD, it's trying to read a block off the USB stick or whatever. And I can always tell why it's not done yet.
Yeah, another one is pipe RD, reading from a pipe.
Mm-hmm.
So so in the German keyboard,
writing to a pipe, and lots of them.
So in the German keyboard, the Z is right next to the T. So sometimes I blindly hit the keyboard trying to do Ctrl+T and accidentally hit the Z. So I sent the progress to sleep rather than getting the info from it. So I have to put it in the foreground.
It again. All right, we'll be back in a minute.
So, time for the Beastie Bits this week. 500 million tries for a Hammer 2 bug. Sounds interesting.
Yeah. Interesting race condition they found on the focus versus modify in Hammer 2. They finally fixed a rare panic when removing a large number, as in hundreds of millions of files, 100 million of directory entries. The ZOP operation code holds the collected cluster lock, but cannot safely, or can't lock it without risking a deadlock against some of the backend operations or dead backends. The hold on the chain prevents its destruction, but does not prevent another thread from locking it and issuing a chain modify. This fixed bugs due to the unsafe nature of the unlocking of the chain's content, especially chain data and chain DIO, by adding an interlock between front-end access to the data and back-end hammer-to chain modify. Held but unlocked chains are used by the ZOP API to pass chains back to the front end. It also removed an automatic, because it is unsafe, DIO synchronization from the hammer-to ZOP collection, and instead implemented an API that the front end can use to safely access the data. The API is hammer-to ZOP GData and hammer-to ZOP PData. And they removed the unsafe hammer-to cluster RData, and they used to use the GData or PData APIs instead. And finally, rewired the hammer-to inode get to pass in a hammer-to ZOP head instead of a hammer-to cluster, so that it can use those new APIs as well. But yes, took 500 million tries to trigger the bug, but now they've managed to hunt it down and kill it.
Yeah, they pretty much nailed that hammer bug. Okay, bad jokes aside, we have another one called OpenBSD with various desktops. So we have a couple of YouTube videos.
Yep,
the first one,
Trio here.
Oh yeah, Tree's company. OpenBSD 6.3 running TWM window manager. And
the next another one with CWM window manager, and then a third one with I closed one too many tabs. Another one with JWM and the ROX desktop.
So yeah, who has ever said that OpenBSD would not make a good desktop?
Yeah, sorry. But if you've ever wondered what these different things look like, you can check out these short videos that give you an idea.
Yep, and of course, OpenBSD makes that desktop experience a little bit more secure.
And then yesterday, we have a commit here from Christoph Provost, who imported some changes from OpenBSD. So this increases the default state table size for PF. This is the typical system now, has a lot more memory than when PF was new, and is also expected to handle a lot more connections, increasing the default size of the state table. And note that users can always override this setting with the set limit states line in their pf.conf. I know that mine is tuned up to a higher value because the default was not enough. And then he copied some of the commit message from OpenBSD where they changed this default, which is kind of a funny read. So from OpenBSD, the year is 2018. Mercury, Bowie, Cache, Motorola, and DEC all left us. Just PF still has a tiny default state table limit of 10,000. Now it's a tiny little bit more, 100,000. Lead guitar, me. With a chorus of Peter Hessler, Theo, Claudio, and Benno, and the background schoolgirl laughing from Bob.
See what kind of fun they have. I guess they have a hackathon going on currently, so we'll see a bunch more interesting commits going by in the future.
Yeah.
So yeah, now that you're thinking, oh snap, I forgot to make backups, well, then it's the right way to look at Tarsnap a bit closer, our sponsor for the feedback and questions section. Because that one gives you the online backup for the truly paranoid people. Secure, efficient, and online backup. So you think, whoa, wait a minute, online? Isn't that exposed in the cloud and everyone can read it? No, because it's encrypted locally before any data goes out into the evil internet. So you can rest assured you're the only person who can decrypt that data, because in case you need to restore your files and you have still the key from your original when you created that one, then you can pull it down from Amazon's AWS cloud and no one else there can grab it and make any sense of it. That's what Tarsnap does for you. plus a bunch of clients available for the most popular operating systems. If you know tar, then tarsnap should be easy to learn. They have a documentation with getting started and a simple usage example, as well as an FAQ where you can find out how much you would have to pay for your actual data set without having to pay the tarsnap folks upfront. So there's a little simulation there, because it's also compressed and deduplicated, so it would typically be less than you would have expected.
Yeah, and it only takes $5 to get started. And it's pay as you go. So you put some money in and then go until you use it up and then put more money in. So you never get a surprise bill. So definitely check it out. Do your backups. You'll thank me later.
Yeah, everyone wants to do restore, but people are afraid to do the backups or too lazy.
Yeah. So tarsnap.com/BSD Now.
Too many snaps around, yeah. Okay, time for feedback and questions. We have been sent more questions, but keep sending them if you have them. Anything, feedback and questions are most welcome for future episodes. The first one is Ben Sims with a full speed question. That goes like the following. Hi, Alan and Benedict. Thanks for all the great work you do. I guess that's not just the show, but yeah. Thanks for that. That goes, I pay homage to show by religiously listening at 1x speed. Okay. I would like to prostrate myself further by listening to all the back episodes. However, there only seem to be a limited number of these in the iTunes feed. Am I missing something? Also, is there any way I can support the show? Thanks.
So for the feed, it
doesn't go back to the first one?
The podcast network switched the way they do the feeds to make it easier for them to produce the episodes. And when they did that, they decided it was easier to start with an empty feed than have all the other ones, partly so that people that were subscribed on iTunes wouldn't end up re-downloading everything or something silly like that. So the downside is I don't know that I have the URL handy of anything that has every old episode. But
they surely are.
Into it, I guess. All the episodes exist and are downloadable. I don't know that there's an RSS feed that makes it easy. I will have to look into that.
Yeah, they're all on the website, but if you have it in your iTunes news feed, then it's not the complete set.
Yeah. Yeah, I don't know. Yeah, I'm not going to have time to go and build that, so I don't know what to tell you. I think the old feed might be around somewhere. I might be able to find the URL to that.
Or someone sent it to us.
It would give you everything up to like March, and the new feed is everything since March. But
yeah, then you can binge watch.
Yeah.
Other than that, anyway, you can support it. Well, you basically are now part of the show in this episode. Spread the word. That's pretty much what comes to my mind currently. We have no Patreon or anything.
Yeah, if you want to support it, best bet is donation to the FreeBSD Foundation.
Yeah, or any of the BSD foundations that you think is worthwhile. Because we're pretty much doing it on our own enthusiasm, so that's appreciated. So thanks for enjoying that, and keep watching and give us feedback if you like something as you did, or if you have any questions, then we'll put you in another feedback and questions episode.
Yep.
Okay, that's for Ben.
But yes,
and next,
good point. Best way to help the show is write emails to us.
Yeah, whether you found something that would be BSD newsworthy, or any show ideas, topics, to feedback at bsdnow.tv, and then we'll have a future episode. See, that's still with content. All right, Scott is next with questions and comments. So this goes. Thanks for a great show. Oh, great. Wow, we always loved hear good feedback. Recently, someone suggested using an access points association table to tell if a phone was nearby, thereby indicating that someone had arrived home. Oh, yeah, I remember that one. It's been a bunch of episodes in the past. So this approach only works for arrivals, but creates false positives for a person departing the area. At least for iOS devices, they disassociate after an idle period to save battery and instead rely on 4G for things like push notifications. I learned this the hard way, house lights going off even though I was home. Oops. I found 2 workarounds for this. So you add your Bluetooth device MAC address to etc Bluetooth/hosts and run something like L2 ping with -a my device. So we have the full command line.
But that would only really cover if you were sitting close enough to the machine for Bluetooth, right?
To reach that, yeah, to have the signal. I use a cheap Bluetooth dongle rights passing through to a VM to do the polling, or install a free app like Home Remote and set up a geofence which you can trigger upon arrival or departure within a given radius. You can specify a custom action. I make an HTTP call, a CGI script on my web server, for example. Okay, and now a question. I have a few IP cameras in my house whose stream I want to re-encode in real time. Do you have any combination of hardware and drivers that will allow FFmpeg to decode or encode H.264 with hardware acceleration? So he has a video.
I've never actually tried to get it going under FreeBSD. But I've looked at the libva QuickSync that's built into many Intel CPUs. And yeah, so he says he's having trouble compiling FFmpeg on FreeBSD. You can just use the port, although I don't know about the NVIDIA bits specifically.
Software encoding is just too CPU intensive. Yeah, of course.
It depends. Like, if it's just an IP camera, it depends how... Most of the cameras I've dealt with are already doing H.264, so we're just repackaging it into like RTMP stream to send it to our live system. But yes, this is part of the reason we tried using Raspberry Pis to build little streaming boxes for conferences. And even though we had a camera that already did H.264, it does it at like 40 megabits, and we need to drop that down to like 1 megabit to send it out to the internet. And the Raspberry Pi just couldn't handle the CPU load.
Oh, yeah. That's a bit too much. Okay, yeah, hopefully that helps you, or someone out there knows how to do this, how to compile it with NVIDIA, or has a different solution altogether, then send this to us and we'll cover it in a future episode.
Only solution I have for that one is my company sells exactly that as a service, but that's, not what we're here to talk about.
Yeah, you can inquire with Alan's company that offline.
So, next question.
Trolls features of FreeBSD 11.2 that deserve a mention. Yeah, as you know, FreeBSD 11.2 came out recently-ish, and that goes, hi Alan and Benedict, I just finished listening to your latest episode of BSD Now, where you talked about FreeBSD 11.2. However, I feel that there are several features that were not mentioned, either by you nor in the official release notes, that really do deserve being mentioned. A big one for me.
Coming up with the release notes is like the hard part. If you're interested in helping with that, FreeBSD 12 is going to be coming out a little bit later this year, and the first draft of the release notes is out. So if you would like to pick through that and find all the things that are missing and mention those so we can get them added, that'd be super helpful. But yes, let's talk about 11.2.
Yep. So a big one for me is that with 11.2, we get compressed send and receive and device removal for ZFS in a -release version, of course.
Yes. Compressed send and receive is amazing, and I love it.
You, of course, deploy that already and make use of that bandwidth saving?
Less than you might think, because all
the videos
of my stuff is video and it's not compressed. But yes, super helpful.
But in general,
databases around.
So there are two smaller changes, Charles writes, that I have been looking forward to. The updated IXL driver provided supports for the 10 gig Ethernet in the Atom C3000 Denverton platform. Okay.
I think we mentioned that driver getting updated, but I didn't mention that specifically. Those newer Atom server grade CPUs now have working 10 gig, which is a big deal.
Oh, yeah. So he writes, I like older AMD Opteron hardware, even more so these days of Spectre and Meltdown. And in 11.2, there's a small but very useful bug fix, he links to that one, that resolves a problem which has been present in several releases at this point, where FreeBSD, even the installer, has been unable to boot in a virtual machine under KVM on Linux when running an AMD Opteron system. The only workaround so far has been to expose the CPU as a really old Opteron series and thus miss out on CPU optimizations. Yeah, this is less than optimal. Finally, a quick ZFS question, if I may. Sure. I have heard Alan mention being able to change compression algorithms on the receiving system when doing ZFS send and receive. I think the example was using gzip for an archive and LZ4 for the live data. How can I accomplish this?
Right. So when you do ZFS send, you can't use compress send receive, and then when you receive it, you're just writing it into a data set where you've already set the compress type to the other kind, and as it writes it, it will write it with that compression level. You have to be careful if you're doing a capital R replication or recursive, because if you copy the properties, it's going to change the compression level to be whatever the other side was. But if you set the compression on the data set you're writing to be gzip, it will write it with gzip, and it'll just take longer. Hopefully, you can wait a little bit longer and have Z standard and not have to use gzip.
Oh, yes. When is that going to happen again?
It's behind schedule at this point. Hopefully soon. I have a bunch of free time this weekend, which I hope to spend on that instead of other things.
Okay. No pressure.
Yeah.
Okay. So thanks to and regards to Denmark for that question from Charles. And last but not least is Fred with show ideas. So writing in. Hello, Alan, Benedict, JT. Thanks for the time and effort you put into the show. Thank you. Matt Dillon of Dragonfly BSD, not the actor, would be a very interesting interview.
Yes.
Or
so
if that's not...
When we asked him years ago, he said when Hammer 2 came out. And now Hammer 2 has come out. And so we've got an agreement in principle. It's just a matter of scheduling. Hopefully, we will have that happening in the not too distant future.
Mm-hmm. Yeah, we'll keep tracking people who we want to have on the show ourselves, because
yes,
it would be interesting to have them in interviews. As it continues, if that's not possible, just a discussion of the merits and or drawbacks of the design decisions in the Dragonfly kernel would also be very interesting. When Dragonfly was...
That would help with questions too, yes. It's like, now that it's, more than 10 years later, what does Matt think of the decisions he made? How many of them worked out and how many of them didn't? And so on.
Yep. Or like, how's the project doing? What are things on the horizon for them, and other stuff like that. And so when Dragonfly was created, MD made some really strong technical arguments in support of his design for a multi-threaded kernel. From the submitter's understanding here, essentially minimizing the use of the traditional fine-grained locking scheme and instead using critical section whenever possible to achieve the same effect. If I recall correctly, one of MD's main points was that a traditional design, multi-threaded kernel, although a proven scheme, was very complicated and that made it too difficult to optimally maintain a project with a smaller group of kernel developers like FreeBSD. Or Matthew Dillon was skeptical on the ability of such a smaller group to maintain a kernel with a complicated locking scheme in terms of scalability, performance on par with competing projects having more resources. I think his concern is in that regard that if CPUs had what could be hundreds of cores, which we have on the horizon at least. It's several years down the road now, and it'll be interesting to get some detail on which of MD's original Dragonfly kernel design ideas have shown to have merit and which did not. Yeah, as Alan said. It seems that the target use case for Dragonfly is more toward clustering, and maybe that's the niche where it makes such a design necessary or advantages. It'd be good if the discussion didn't turn into a comparison of good versus evil. There's always trade-offs. Thanks for the show.
Yeah, I know that FreeBSD didn't end up going the way it looked like they were going to when Dragonfly forked off. The idea they went with didn't work out so well, and they came up with a different one after that. And so, yeah, look forward to having that discussion, but in a productive way, like you said.
Yeah. And I mean, in an interview, we ask questions, people answer, and there's this dialogue going on, and we're not too much doing any comparisons because we want to hear different perspectives anyway. So, but that kind of wraps up this episode. Again, thanks for listening. And yeah, if you find something on the internet that we haven't included yet, send it to feedback@bsdnow.tv and we'll fill it in a future episode. Thanks for watching.
See you next week.